My name is Samara Garrett, and this is my individual video for the course ICS 382 Computer Security under the instructor Jennifer Grant at Metropolitan State University. In this video, I will explain SQL injection and then run a demo to show how SQL injection works and one option for what can be done to prevent it. This video is solely for educational purposes, and I'm not liable for any damage that could be caused by using any of the included information or demonstrations. First, I'll give some background about SQL. SQL, or SQL, is a language for extracting or managing data in a database. It was developed at IBM in the early 1970s. Originally called SQL, for Structured English Query Language, it was later changed to SQL, Structured Query Language, due to a trademark issue. It's the standard language for relational database management systems. Most web applications that integrate a database use a database management system that is based off of SQL, such as MySQL, Oracle, PostgreSQL, etc. Why would a web application need to use a database? Any application that allows people to log in or sell something online needs to keep track of information such as login and personal details, product details, customer payment information, etc. SQL has two parts: the data definition language, which is used to create and drop tables and grant and revoke access rights to database objects, and the data manipulation language, which is used to manipulate data in the tables through insert, update, delete statements, and select statements, which query the database and then show information from the database to the user. Here we have the basic form of some common queries. The words in red are reserved words in SQL, so they can't be used for things like table or column names. For the data definition side, we have create table and drop table queries. Create table creates a new table with the structure given in the parentheses. Drop table fully deletes a table from the database. For the data manipulation language, we have insert, which inserts rows into a table, update, which updates rows in a table, delete, which deletes rows from a table, and select, which returns rows of the given columns for one or more tables for view. Select is the only one of these queries that does not alter the database in any way. Code injection is a hacking technique that exploits bugs in code caused by processing invalid data. It involves attackers introducing or injecting code into a vulnerable system to change its execution. This can happen when an application sends untrusted data to an interpreter. SQL injection is a type of code injection. It involves the use of SQL queries to view or edit information in a database maliciously. Though it is most known for the damage it can do to web applications, it can also be used to attack any type of SQL database. There must be a security vulnerability in the code for SQL injection to work. Most commonly, this vulnerability involves user input not being correctly filtered. SQL injection is currently the most common form of attack against websites, both in frequency and success, comprising 2/3 of all web app attacks. If a vulnerability exists, SQL injection is incredibly simple to pull off. It requires only a single person, with a single computer. Things that can be done with SQL injection involve pretty much anything that can be done with an SQL query. So this includes using or modifying a select statement to get personal information from databases. This can be anything that a database has saved, which has in past SQL injection breaches included anything from names to login information, social security numbers, credit card information, etc. A insert or update statement can be used to create an admin login for an attacker, which would give them all the rights and privileges of an administrator. Or even using drop table or delete to delete tables, rows from tables, or even the entire database. So better hope that you have a backup. Here's a list of a couple of recent SQL injection breaches at the time of this recording. I got these from the SQL Injection Hall of Shame on the Code Curmudgeon website. The link is in the description of this video under my references. June 2019, Medical Informatics Engineering, 3.5 million patient records exposed. May 2019, Amadeus IT Group exposed data on 700,000 visa applications of Israeli citizens. April 2019, duplicate page WordPress plugin, 800,000 sites exposed to a vulnerability to SQL injection. And similarly, in April 2019, Google Maps WordPress plugin, over 400,000 sites vulnerable to attack by SQL injection. If all of these horrible things can happen due to user input, why take user input at all? Why not just never take input from the users? Well, login details have to be sent to a database to be validated. Websites that sell things have to take user input for addresses, payment information, etc. Any website that has a search feature, the search terms have to be sent to a database to search. Choosing not to use user input in queries is just not always an option. Also, even if you don't intend to take user input, JavaScript may be utilized to change drop-down menu values, so attackers may find places to pass user input that weren't originally intended for that purpose. So now we're on to the demo portion of the video. I'm using a small web application that I coded. I created this for this explicit purpose of this video. Never try what I'm about to show you on a real web application or website, because SQL injection is illegal when used to hack, and you can also cause damage to a real website. Pull up the application here. So this is just a web application I created. Got the code in here. So I've intentionally left this unsafe. If you see here, we're taking the username from input and we're just slapping the username right in there in the query. So this is a select statement meant to validate a login information. If you might notice that I have a little multi-query here, which isn't what you usually use, but my version of PHP is recent enough where it actually prevents you from even having a couple of vulnerabilities that could happen. So a lot of web applications will be built on an older version of PHP, and they will have this vulnerability just happen sort of naturally. So we're going to go ahead. We have a couple of, here's the database, and I have a couple of logins here, and this is just meant to represent which of these are considered administrators. So 0 is false and not an administrator, and 1 is true, so that is an administrator. So if we log in with the non-administrator, it says logged in as a regular user. And then if we log in with the administrator, it says logged in as administrator. Okay. So what we're going to do here is we're just going to add a little bit in here. So what this does is sort of truncates this query here and just adds a new query that says update logins, set is admin to true, where the username is this test person. So we're going to just slot that in, hit submit, and in the database now you can see this test login is now considered an administrator. So if we log in with that test, we're logged in as an administrator. So that's a way that an attacker could get all the administrator privileges in a real website where there's actually privileges allowed. So just gonna switch this back. On to the next part, in which we'll fix that vulnerability. All right, what we're going to do is, I already have this code prepared, so we're going to just comment out this unsafe area. I'm going to comment in this code right here. So what this does is we're using prepared statements, which is, it's considered the best defense, I guess, against SQL injection. It sort of creates a statement object to do the actual processing, which we then send the input parameters to. So this treats the username input as a parameter rather than part of the query, which allows the database to distinguish between the code and the data. If an attacker uses the input like we just did, the query will simply search for the entire input in the database, rather than use the input as part of the query. So we can just take this image just used. Okay, so we're doing the same thing that we just did, which changed the database. And we're gonna submit. And it says username not found, which means that it looked for this entire thing in the database, and obviously that's not the username. So if we go here and check the logins, again, it didn't change this thing to an admin. So the SQL injection did not work in this case. This is the code specifically for using prepared statements in PHP. But the basic concept of prepared statements is the same across a number of programming languages. The Open Web Application Security Project, or OWASP, has some great resources for preventing SQL injection. I've included the URL for their SQL injection prevention cheat sheet in my references in the description of this video. As you can see, the prepared statement code is not much more complicated than the vulnerable code. It's just like maybe a little bit longer. So if it's so easy to do, how do SQL injection vulnerabilities happen? Like why aren't all developers just using this when you're done? Well, companies often push developers to get code out quickly, and then the companies rely on adding security to the finished project, rather than considering security as part of the design process. So a lot of developers, they don't know much about computer security, they wouldn't know that this is important, and the company wouldn't tell them to do this because, well, we can just do security later. The idea is the app developers write the code, and then the security people, handle security. But under this type of design process, obviously, vulnerabilities like this can happen in the underlying code, and then it's incredibly difficult to fix this type of vulnerability. A web application may use thousands of queries in its code, so figuring out how to fix all of that, if you don't start from a good basis, it can be just impossible. And you might, fix 99% of them, and then hackers have all the time in the world to find that one spot where your application is vulnerable. So it's really important to be considering this type of security right from the design process right from the beginning. All right, that's my video on SQL injection. Hope you learned a little bit about SQL and SQL injection, and hopefully how to prevent it if you're ever part of the development process for a web application. Thanks for watching.